Good morning, everybody. Welcome to first ever Update Conf. Are you guys excited? Very excited, I can see that. It's a very American way. I come from Finland. Hello, my name is Karl. We are very shy, we are straight to the point. We talk only about things that we actually feel. So if you ask a Finn, for example, how are you? They will essentially tell you their life story. So don't do that. But do ask us very specific questions about technology or how are you doing today regarding the weather, something like that. All right, let's get started. So as I mentioned, my name is Karl OTS. I work at an Azure company called Azure. And I'm also doing these security sessions. So it's very interesting to do all of these phishing and non-repudiation sessions about, I have an Azure.com domain and a Azure.com email address, so it will be a lot of fun to do this portal.azure.com and a.azure.com and Windows a.azure.com, and you can figure all of the rest as well. So I'm a Microsoft Azure MVP and a Microsoft certified trainer, as well as a certified information security something specialist. And I also have conferences and user groups back home in Finland that I run as well. And I've been working with Azure since 2011. And my day-to-day job is really to go to different customers from the kind of smallest startups who wish to become the greatest scaling application or game in the world globally, or even up to the highest corporations, enterprises in the world. So I see tens of different customer applications and these overall enterprise environments in my daily basis. And that's actually what this session is about. I do give you some level of what is the current security posture on customers, and I also do give you a little bit of, let's say, theoretical background in there. But mainly, this is a huge rant. It's 50 minutes of me ranting about what sort of things that I have seen people get wrong with their Azure environments and Azure applications specifically. Why is that bad? It's not just pointing and laughing. It's about a little bit of defining why is this a bad behavior, why is this a control that will fail, how do you even fix that? Maybe it's not like call me. It's hopefully something that you'll get something out of this session as well. And also there's a bunch of resources, links to tools and documentation in the end of this session that you can take. And hopefully, regardless of what is your current state or current security posture in Azure, hopefully you will be able to improve on that with those tools available. But just to get everybody again on the same level, let's start with this classic what is cloud type of approach. So this is this infrastructure as a service, platform as a service, software as a service matrix that most likely you've seen a couple of times already. But essentially this idea is that we have different responsibilities here in blue. It's our responsibility. If we are on the on-premises side or if we are dealing with actual physical hardware, if it's something that I can go and say, point to a blinking light and say, now this is my server or this is my network that's running, we are from the security perspective, we are responsible for all of these issues. So we are responsible of data classification. So with GDPR, most likely you have had some fun the past couple of years with this. Then we have, of course, the actual clients and endpoints that if we are building web applications, which most likely with cloud we are building, there are some endpoints that we are opening, at least HTTP, HTTPS, stuff like that. If we are dealing with fat clients, clients are always a problem, also with software. And then, of course, identity access management, the actual application level controls. So even if we are authenticating and authorizing our users in our application level nicely, if we are still using one kind of static account to access our database in the background, or if that's in a the connection is in an unsecured way, then of course we are screwed anyway. And then we have the network virtual machine level, and finally the physical level. And of course, when we move your left, my right, on this spectrum of cloud service models, as we move along the infrastructure as a service to the platform as a service, and finally even to the software as a service side, we no longer need to care or can't even influence what's happening with the physical security, virtual machine, hosting level. So we don't get to deal with Hyper-V configuration, or we don't get to deal with how is the physical facility hardened. We just have to trust, in this case, Microsoft, our cloud provider, to do this. And finally, in the end, on the software as a service side, we only care about which data do we put where, and that we have classified it, that our clients that we actually use to access that data are safe, and then who is actually even able to access this data. So essentially, the more control, the more power we get, the closer we get to the physical servers, the more responsibilities we have. So as someone who wants to take on new challenges from time to time, I'd like some big guy like Microsoft to take care of most of the stuff in there. So I build and I encourage everybody to take a good look at how Microsoft is doing the security, and then focus on reaping as much of benefits from the platform as a services side as you can. But in some cases, of course, you need to add some security controls or build something on a kind of lower layer as needed. And essentially, when we go deal with Azure, we can add a ton of security controls depending on what is the kind of, let's say, risk appetite, which is apparently a very valid term for defining how much risk you want, or how much risk you are comfortable with. And essentially, we have these sandboxes or limitations of Azure management. We have management groups, security groups, resource groups, subscriptions. We have our users that are getting authenticated there. We are building our infrastructure through Azure Resource Manager templates. We can add some policies to enforce how do these templates look like. Of course, logging, auditing, encryption, backup, disaster recovery. This is all the stuff, these three are all the stuff that we have been dealing already. Privacy and compliance is also an interesting one, because in Azure, as in security control, it could mean that we are not using specific Azure data center regions, or we are not using some specific Azure services. If we need SLA, don't use AKS. If we need some services that are not available in our region, don't use them. And then, of course, we have the network security, which is still as valid, but a lot different than in the physical or even this SD-WAN world. It's a lot of different virtualized networks abstracted on top of each other, and sometimes it's a little bit hard to get your head around how many levels has this, or how many times this has been already unblocked in order to get to me. So what is my role of adding some ACLI rules or some web application firewalls on top of that? So this is the kind of palette that we have that we can use to secure our Azure applications, and more specifically secure our whole Azure environment. And then let's take a reality check. How well do we do with this? There's a bunch of stuff in here. I just like to highlight this one. This is number of unique security failures across all resources. This is something that the whole dashboard that you see is a scanned result from an enterprise customer. They have been running Azure with their virtual machines and also some platform as a service microservices, meaning multiple monoliths talking to each other, which is usually what we do in the field. And they've been running this 4 years, maybe something like that. So they have some history. They should know a little bit what they're doing. But this is a scan across their I think it's like 10 or so subscriptions. You can actually see there's a unique resources, around 200 resources, nothing too bad. And these are now the how many failures, or which are the kind of top failures that we'll see in this customer. Let's not show the numbers yet, but there's Azure virtual machines missing updates. There's storage, Azure storage accounts with the encryption turned off, or the encryption not specifically turned on. The same for Azure SQL database. The auditing is not enabled, which is fine. Of course, there's some extra cost if you're doing some testing, development, whatnot. These were not. And then we also had the same on the SQL server and SQL database, or SQL database server, which is very funky way of talking about platform as a service, and then the database layer as well. And then we have the Azure App Service allowing unauthenticated access without going through the Easy Auth or the Azure AD authentication. And you'll see that from these numbers that number one was storage. They didn't do anything with their storage. They didn't have any control. Previously, when you went next, please create me a storage. Please portal, please create me a storage account. The HTTPS was not enforced, and the storage at rest was not enforced. You needed to specifically go ahead and click to enable those. It's changed a little bit to the better, but it doesn't change the fact that if you already have some existing storage, you need to still do something about it. And then we have the typical, the missing updates, the unauthenticated use. So this is the reality. We have a lot of controls, security controls that we could use. We know that we are not good, or we know that we are not perfect in using those. How do we get started? And before I go too ranty, let's take a little bit of theory to start with, because administrative access to Azure is where we actually start. What do we mean when I say go to the portal or use Bash, Azure CLI, use PowerShell? We always need to authenticate ourselves to the Azure Resource Manager. And we do that with something called role-based access control, which is based on a mathematical model called rule-based access control. But as Microsoft, they did a little bit of rebranding on top of that, but it's fine. The idea is that we should always have specific roles that have the same set of access regarding who is that assigned to. We don't assign one particular user several different administrative rights or several different permissions across the whole portfolio. We give them a predefined role that they can use. And these are the three main roles. You might be very familiar with this. First one, the most powerful one, is the owner. The owner is actually the super admin. It's not just that you can remove, create, delete, modify, create any sort of resource groups or resources. You can actually do the same for your user access management. So the owner is essentially somebody who has an invisibility cloak. They can delete all the logs because they have all of the ownership. They have unlimited black Amex card because if they can create any sort of resources, they can also create any sort of costs. And then they also have the ability to essentially kill all the security cameras and invite all of their friends in. And as an owner, if you have access in any way in Azure as an owner, you can invite anybody, not just from your organization. It doesn't have to be from your Azure AD. It can be carlshacker@live.com. It can be something from China. It can be something from anywhere. It doesn't have to be a corporate account. It doesn't have to be any way proven that this is who they are. And once you invite them in, if you give them the ownership, then they can kick you out and invite their friends, and the circle goes on. So don't be owner. You can own, but don't be the Azure resource role-based access control owner level. You can be contributor if you want to have all the power to essentially administer. Make all the changes necessary, but not just the user access side. That's the contributor. And then we have the reader, which can read all Azure management layer stuff, everything that the Azure Resource Manager can read. But for example, they cannot read data platform or data plane level stuff. They can't read storage account secrets. They can't read some data inside. So if they have reader on your SQL database, they don't get to have your connection strings, or they can't read actual data from your SQL database. They will need a SQL database user to actually access that data. They just see the resource. They see how much it is used. Their CPU usage is this many calls, but they don't get to actually play around with the data level in there. And this is how we assign them. So we have these roles: owner, contributor, reader, and then we assign this specific role to either a single Azure Active Directory user, a group of users, or a service account that in Azure AD we call them service principals. And then we assign it to a specific scope. And the important part here is that the access is inherited here. So if I get an access here on the subscription scope, it flows to all of the resource groups and resources that are or ever will be in this scope. But if I give only access to, let's say, the resource group C here, then I have that particular access. And for example, if I have owner access to this resource group, I don't see any other resource groups because I don't have reader access. But I can invite anybody to play around with me on this resource group, and I can see all resources that are already created in there, and I can maybe even delete them, add some new ones on my own. But there are some scenarios where we actually need to get more access than just that specific resource group. The best scenario will be that I will just get my own resource group and I will play along with there. There are some Azure resources that want to create their own resource group on the background, AKS, Databricks, and there are in some cases where you need to do some subscription level stuff in order to enable some features on the Azure resource group that you're playing along. So in some cases we need to get higher level of access both on from contributor to owner, or from resource group to subscription, or resource to resource group. So for that we need to have something called privileged identity management. And privileged identity management is actually both kind of theory, but it's also an Azure AD feature, which essentially goes ahead and finds all your administrative users in your Azure environment, and it gives us this just-in-time type of administrative access. Which essentially means that we can elevate our rights. By default, I'm a reader. I can go ahead and click, please give me contributor in this same scope. We can add some authorization. Your manager needs to approve. We can add some workflows that I need to sign in with MFA. I need to maybe type in a reason, a ticket ID that's customizable there. And then we get actual logs and access history from that. These are all very nice, but it does require the highest tier of Azure AD called Premium P2. At least those customers who I see don't have this, because there's this certain caveat that if you want to enable it, it is per user. You can turn it off after 1 month. It's kind of flexible, cloud licensing, whatnot. But it just so happens that you need to turn it on for all of your users on your Azure AD, not just administrators. Well, typically you also use the same Azure AD to manage, your AD, your Office 365. So it could be thousands of users in there. And even if the cost is 2 or 5 or 10 euros per month per user, it doesn't really matter if it's multiplied by so many times in a larger environment. But it's nice if you have it. And you can just steal with pride the same logic. All of that is actually doable on your own or through group management, stuff like that, so you don't have to pay for that license. But it's something that it makes it easier to present to the business or to your managers that should we buy this? This costs 200,000 per month, or should we spend 2 weeks or 2 months with a team of 5 people to build this? You know, return of investment, 6 weeks. All right. And then specifically for security, we talk about different threat modeling or threat models. And these are just ways of talking or formalizing the different threat vectors that are affecting our system. It's essentially this very US style of lists that there's a nice acronym, and then if you go through whole list, then you're sure that you haven't missed any of these threat vectors. And as a caveat, yeah, of course, we know if you use platform as a service, we don't have to care about the whole attack surface, but we need to still evaluate or model the threats and see if what Microsoft provides us is enough. And Stride is a Microsoft model for this. This has been around for 10 or so years, and it stands for spoofing, tampering, information disclosure, denial of service, and elevation of privilege. And funnily enough, typically we don't talk about these when we talk about the reverse ones. So the property, so this column here, this is the one that we actually talk about when we say that there are risks related to the integrity of data, or we need to add some authentication controls in our application, right? But we are modeling the risks, we are modeling the threats, so actually that's why we have the spoofing, which is the risk that we mitigate with authentication, right? And just real quickly, essentially spoofing is me claiming that I am somebody who I am not. Tampering is about modifying the code by somebody who is not able or should not be able to do that, either through SQL injection, something else. Repudiation, or specifically the non-repudiation, is that I did something, I sent an email with an order, or I said that yes, I will order this magazine, and then I call back. Then I later claim that I didn't do this. So that will be the kind of non-repudiation. If the email server doesn't keep logs, then there's no way to prove that I sent it. Usually emails are archived, and this is something that if you're dealing with enterprise systems, very day-to-day business for you. There might be regulatory reasons for us to do that. Then, of course, we have the more familiar ones, the information disclosure, denial of service, elevation of privilege in there. And this is all part of the Microsoft Secure Development Lifecycle that can be applied to not just cloud, but any type of software system or other system. All right, but enough with that. Let's get on with some ranting. So essentially, one of the big things when I go to any sort of customer and I run any sort of, I even don't have to run this sort of scanner that I showed you at the beginning. I just ask them to please log into your Azure environment and show what you have. And the first thing that usually is there that everybody's the owner. And hopefully if you take one thing away, don't be an owner. So that's bad. And even worse if it's in this subscription scope. And to be more pedantic about this, why is this bad? Remember last slide. So from the Stride model, of course, there's at least the tampering, meaning the bad person, bad attacker, modifying the data. And of course, if we don't know who they are, and if they have all the access to kick me out, or all the access to kick everybody else who will monitor that out, or if there are somebody who they don't claim to be, spoofing there as well, then they can modify any sort of data. Reader doesn't have access to our secrets, but contributor and owner have. And of course, information disclosure, they can make a typo and invite somebody who should not be there. If Microsoft would have users or email addresses with azure.com, I'm sure someone will make a typo and send it to Azure.com at some point. And given that we manage our own Office 365, we can kind of customize whether or not somebody actually sees that typoed email or not. All right, and obviously, how to mitigate this type of risk? Subscription should never be the default way or default scope that you will get. As a developer, as anybody, you should at maximum get a resource group level. You can do everything. You always need to put your Azure resources in a resource group anyway, so why do you need that subscription level access? And of course, you should be the contributor at maximum, not the owner. This is warming up. Let's let this sink in. All right. So the next one is relatively the same thing, but it's about the service principals that I mentioned in the beginning. Service principals are used to log in to Azure with just a key value pair. It's an application ID and a secret. So there's no way of knowing who is actually using them, right? So it can be our DevOps pipeline, or it can be a bad attacker who stole our credentials from somewhere and is using that. We can't be sure, we can't enforce multi-factor authentication. It's not even interactive. And this is the other big thing. Even if you have set up so that you are not using your own personal credentials for automated deployments, for example, typically, and if you just go next on the Azure DevOps, formerly Visual Studio Team Services, formerly Visual Studio Online, formerly TFS on the cloud, something like that. If you just go next and add this pipeline to my Azure, they will actually create you a service principal in the background with a whole subscription as the owner, as the scope. So don't let it, just create a service principal or ask somebody to create the service principal manually, assign it the proper scope, not subscription, the actual resource group that you want, and then configure that for your Azure DevOps or the other tools. The worst cases that I've seen is that somebody's just a developer who doesn't like GUI. I've heard of some people who don't, who just want to use, Bash. I just want to log in from my CLI. They don't really like the Microsoft device login type of thing that I need to type some code into a browser, that kind of stuff, or MFA. So they might be inclined to using it. Okay, so if I just store these as variables, I can just run this line, and I'm always authenticated, and I don't need to type anything manually. Nice. No, don't do that, because it's unsafe. It's only the key value pair, and then you're screwed. If you lose that, you're screwed. And the big thing here is the repudiation, which is threats involving an adversary denying that something happened, is the definition. And it's exactly that. If you, as a super admin with 3 screens and a human-sized hamster ball, are using service principals to log into Azure, and somebody else is doing that using the same service principal credentials, we can never be sure who actually, deleted all of our data. So if you get fired and then all of the data just magically disappears, we don't have really that case again for you. We might suspect, but we can't really prove very easily that it was you. Or the other way around, if somebody else steals it and frames you. And of course, yes, service principals should be assigned not automatically, but manually, and should always involve the same sort of logic as with actual users or groups. And with the least privilege principle, of course. And the service principals should by default never be granted in subscription scope, or rather we should automate the assignment of service principal access. And yeah, the second part is a little bit harder in terms of laziness, but the last part is that you don't have to even be lazy. There's just no reason for you when you are making that you're running one line of code or you're clicking in 3 wizards, or if you're using PowerShell, 3 lines of code. AzSK is for the best in this case. So you're just running one line of code. You are defining in that line whether you are assigning that service principal, contributor, owner, reader, whatever other role. There's no reason for you to give that service principal owner account ever, unless you're building your own privileged identity management type of system, maybe. All right. The next one is actually something that creates a little bit more confusion. So this is about Azure portal being very sucky at telling us who is actually the user behind this email address. So this means that people can invite anybody. As I mentioned, if you're an owner, you can invite anybody with this email address. And with the same email address, I could have a Gmail account, an Azure AD account, Microsoft Live account, or the Microsoft account. Personally, I have a Live ID account with a domain name that I haven't owned for 15 years, but I can still log in with that kind of primary ID. I can't receive, of course, any emails to that, but that can be, I can still work around that. So Azure portal isn't really good at telling us when are we using which of these services. And remember, we can't force them to use just Azure AD or some other. So essentially, this is now about this spoofing part. So essentially, I can have a Gmail account with Azure.com, or you can have with your corporate account email address. It looks like your enterprise.com address, but then actually you're logging in with some personal account. And first of all, you can then share that to anybody. There's no corporate governance. We can trust that you are using a multi-factor authentication, anything like that. And also, there have been cases. Every year, there's a case where these personal accounts get attacked or phished. Somebody just calls Yahoo or Microsoft or Google and talks their way through of resetting your, for example, Gmail password. I think it was a Ars Technica editor who actually got stolen his Gmail account in this type of way. It was purely by the lack of process in the whoever Google outsourced the service desk, actually, in this case. And then, of course, the elevation of privilege. If I invite somebody else, if I invite any of you from your Azure AD, even if it's not personal account, if I invite you, then there's a risk that if you have a bad vector in your environment, and Azure Active Directory, global admin, can actually manually go ahead and take over your Azure. Well, first of all, they can just reset your passwords, but they could also go ahead and take ownership of your Azure subscriptions there as well. So there is this elevation of privilege, or it's very similar to this kind of trust or federation model in this case. Yes, and as it turns out, do the reverse. So always use your own Azure AD, or if you partner with someone who you really trust, and preferably as a mitigation, use the privileged identity management, because it keeps on logging and alerts you on all of the changes and all of the usage of these elevated rights. All right. So very tragic, but something that we had there as well. So unprotected public endpoints. So first of all, most applications that at least I see running on Azure are either fat clients for something IaaS or just web applications. And with the web applications, and also mean APIs or services talking to each other. So there's always some sort of networking component involved, and very often that is left unprotected. Previously, because Microsoft defaulted to no security, now they default to some obscure security when you create in a wizard, which most people still do, VMs or app services or these others. And this is something that I shouldn't be here telling you that this is bad, but I see this so often that I still have to. So yes, obviously, if there is a unprotected endpoint, somebody who is not supposed to can get in, and then our confidential data might get leaked, of course. Or if there is no availability-related control in this public endpoint, meaning a load balancer or a web application firewall or app gateway, or in case of APIs like API management, API gateway, all of those, if that's not in place, we can have a denial of service type of attack there as well. And that, of course, degrades the availability of service to our users. So obviously, every public IP address is at risk, and you should always have a reason of having a public IP address in Azure. Anybody can just go ahead and download an Excel file with all of Microsoft Cloud's Azure, or essentially even, it's very detailed nowadays, you can go ahead and download a list of IP addresses that are in Western Europe in Azure. And that, of course, means that whenever I open anything up, a new VM without, or even like an RDB port or SSH port open, in 15 minutes I get tons and tons and tons of authorization or trials of login. If you're dealing with virtual machines, yes, add at least the network security groups. They're very easy. They are access control list type of firewall. You define from the source and destination of traffic, the protocol, and whether or not you allow or deny it. Very, very simple. Then you have also Azure Security Center's just-in-time access. In theory, it works in a way that by default it locks everything down, and you go to a just-in-time access portal, click on please give me access to this virtual machine, and then it opens up the port to your, it essentially dynamically changes the network security group rule, enabling from your IP address to access that VM. But it still opens that port, and for the first year when the service was available, the Linux support or SSH support didn't work. So when you opened the NSG rule for SSH through just-in-time access, if you kept your connection open, the port was still open. So it didn't change back the network security group rule. Now it finally does, but it took a lot of time. And then if you have like any sort of HTTP endpoints, if you have web applications, you might think of adding a application gateway or even the web application firewall. It's essentially Apache ModSpark as a service, and Microsoft takes care of scaling that for us. If you have APIs, then just put everything behind your Azure API management, and the same approach is still valid. All right. I do realize there's a session after this related to keeping your credentials out of your code, so I'm not going to spoil too much on that side, and Keyvault is surely a good tool on that. But in terms of evaluating an application, if you find yourself using directly a storage access key for accessing your Azure storage account, you're doing it wrong. Very, very, very simple. Again, it's all you need is the storage access key and the name of your storage account, and then you can do anything. You can pull in any sort of data, you can delete any sort of data, you can download, modify, you can tamper with the data, all of that without leaving a trace. By default, storage accounts are not monitored on who is accessing them where. Yes, you can enable some monitoring, but then you still have to manually go ahead and retrofit that maybe on the timeline, maybe this was the same user, but it's not exactly, at least on the forensic level, it's not proof on that. So it's the shared key. So obviously, yes, your valuable data that gets leaked, somebody might change it, and the same with the service principal. As long as it's a shared key, anybody can claim to not have been the one using it. So how do we work with that? Because we can only have two keys that are valid at any given time for our Azure storage account. So we can store them in any sort of key vault. Azure Key Vault is a very good one because it's in Azure. There is some automation available for us. So there is a group of PowerShell scripts that you can run to enable essentially key rotation programmatically, essentially meaning that you never ask directly from storage account what is your key. You always ask from key vault / storage account name / key, and you get always the fresh version. And on the background, key vault and storage account are talking to each other and switching the keys or rotating the keys all the time. I mentioned that typically reader permissions are not able to get this storage account key. I said they don't have access to secrets. Specifically, if you are creating a custom role or if you're creating a deny type of role assignment or anything like that, or if you're creating policies, or if you want to dig deeper what is specifically needed on Azure role side, because sometimes I want to have contributor on everything else except here. There are some scenarios where reader is just not enough. So what you need to do is limit this specific Azure storage resource provider action storage account -list keys -action. If you decline access to this call, then you don't need to. Then the user doesn't get those storage keys displayed. All right, and some PowerPoint magic there, but then the monitoring part. This is the whole other topic of mine this afternoon, so please join me on my monitoring session then. But this is also something that gets very, very poorly implemented in a lot of the cases. When we use platform as a service, we might think that, okay, Microsoft will take care of monitoring. It's not the case. Most cases, yes, they will, but we need to enable that. There might be a cost effect, or there might be some standard retention times. For example, Azure activity logs who monitor all types of these Azure resource provider activities, role assignments, these list keys action, all of those. Those are only stored by default for 90 days. And if you read most of those news, you might hear that typically an adversary is in a customer or in your environment for 200, even 500 days before they get found out. So 90 days doesn't really cut it for us in terms of auditing that. Yes, so how to mitigate it? Yes. Please configure your activity logs to be stored for more than these 90 days. For a very easy, simple win or quick win with high impact, you can enable Azure Application Insight without actually touching your code. There is code time instrumentation and there is runtime instrumentation. So as long as you have any sort of application running on your Azure App Service, you can just say enable Application Insight, and essentially just talks with your IAS logs and creates these machine learning alerts for you, which can be actually very useful. So those machine learning alerts are, for example, like this. Hey, we noticed that you are now getting 200% more of error, HTTP error 403 unauthorized than you typically get in the sampling period that we have. There might be a problem. Or, hey, you're getting IIS error or HTTP error 500, so internal server error, and it's like abnormally abnormal the amount of calls that are getting made to your application. Please check it out. And I actually have a customer where they noticed a DDoS attack from Application Insight Smart Alert before, and they had an operator who was tasked. They had these DDoS scrubbers, and they actually had purchased a service for a telco to monitor that same thing. And the customer was like, "Oh, an alert, but I haven't heard anything from the telco, so that's probably nothing," and just went back to eating. And then another alert, and there's, "Okay, please guys see what's happening." And they're like, no, we don't see anything in our monitor. And almost half an hour went by before they actually started noticing that network level activity, because this is a very sophisticated targeted application level attack. If I know you're running an HTTP server, and if I crawl there and see which pages you are, it's very hard for some sort of automated WAF or scrubber to notice that is this bad behavior or good behavior. So very easy win, doesn't cost us anything to enable these application log smart alerts. And then for different Azure services, we have this advanced threat protection. For some, it might mean Azure SQL. For Azure SQL, it means similar this kind of machine learning alerts that, hey, there's a SQL injection perhaps happening, and hey, we noticed that there's some abnormal usage from this application. Do check it out. Different Azure services call it a little bit differently, but usually it's under this ATP. And then for Azure SQL, yes, enable the logs. You pay storage account costs, but that's it. And if you put in an application gateway or WAF, it's good, but you also need to monitor that activity, especially because the configuration isn't really that good, meaning that there's a lot of debugging that you might need to do. I still have time for this one. So very quickly, as I pointed out at the beginning, this is something that should not be happening, but still, if you run something on Azure on virtual machine, yes, Microsoft does give you an SLA that is up and running, but first of all, by default, it's not configured at all, or even worse, it's configured in a bad way. So there's a lot of things that you need to fix and kind of harden your host. And then also, yes, you are still responsible of updating your VM. Microsoft doesn't do that for you. If you want that, you can still go back to the cloud services, the older platform as a service generation. Virtual machines need to be updated as with any other virtual machines. It's even bigger risk because, as we mentioned, all Azure IP addresses are available. If you don't care about updating your VM, you most likely don't care about protecting your RDP endpoints as either. There's automation and tools for that. Azure Security Center tells us explicitly which ones do we need to patch, which are critical, which VMs are missing. All right, let's wrap this up with some tooling. If you want to run similar scans that I did at the beginning, check out the Secure DevOps Kit for Azure, AzSK. This is a tool not built by an Azure product group. This is a tool built by Microsoft IT, or how they call it now, Microsoft Core Services Engineering, who is responsible of hosting over 1,000 Azure subscriptions and even more applications by Microsoft on Azure. So they also need some sort of security in there, most likely a pretty good security. So it's a set of tools, very easy to use. It's non-intrusive. You only need reader access to run. It's line of PowerShell. You get a nice report back on what's wrong. And you can expand it to automate with your Azure DevOps. You can expand it to, you can even create a nice PDF, 100 pages long. It looks big. You can stomp it on the desk of your vendor or your boss, whichever you want to kind of intimidate. Then we have some other links. So the AzSK is found at azsk.azurewebsites.net. This slide deck will be available at my SlideShare. And also, if you want to learn more about AzSK, shameless plug, please check out my Ignite session with the code there. If you want to learn more about Stride, one of the eventual or actual creators of Stride model, a researcher from Microsoft Research, did a nice analogy with Star Wars, with non-repudiation, meaning that the helmet of the stormtroopers is, I can claim that I'm somebody who I'm not, because only way of seeing that whether or not you are fit to be a stormtrooper is the height of the person wearing the helmet. So that's not really identifying in there. And there's a lots of other these as well. If you want to kind of put your mindset from how do we build traditional data centers, how do we use the onion model or some Cisco defined blueprints about networking, please check out Azure Virtual Data Center. That helps you map traditional networking versus the Azure virtual networking, and what should you do if you want to build this kind of DMZ type of approach in there. And then there's the Azure Security and Compliance Blueprint, which is not the Azure Blueprint feature, which is just a bunch of links with reference architectures with different scenarios and security lists on those. All right, I'm running out of time. Last shameless plug, if you like Azure, join us in January in Helsinki, Finland. We have a conference called IgluConf. It's literally the coolest Azure conference in the world. It's 2 days Azure only, and if you're up for it, you can grab a code here where you can get a 20% discount for that as well. All right, with that, I am officially out of time, so I thank you very much, and I'll be at the Ask the Expert lounge after this session as well if you want to grab some extra questions from me. Thank you.